All right, so we're going to finish up chapter 23, and we're going to talk about some unique inheritance patterns. So Mendel looked at complete dominance. That's really what he focused on. And so he said that in every single characteristic, there are two types of alleles that control that characteristic. But in reality, there can be multiple alleles that affect one specific gene. And so this is known as multiple allele inheritance. It's not just big S, little s. You might have big S, little s, or big T, little t that might control the same gene. And so blood typing is one of the best examples of multiple allele inheritance. And so we use the letter I as the indicator for blood, and then we put a smaller letter, actually a superscript of a capital A on the blood cells that have A antigens, and we put a B on the B antigen blood cells. So A and B are co-dominant, which means they will be expressed equally in equal amounts. And they're completely dominant over little I, which is considered O blood type. And so down here you see the genotypes. You could have big A, or so I big A, or I big A, little I, and you're going to have the phenotype A. Here you have B. The only way you get AB is if you have a big A and a big B on your eyes. The only individuals that are O blood type are going to have two little eyes. They're recessive. So because I do things a little differently, this is the same slide, but the way I write it is A is dominant over O. So to have A blood type, you can have two A's, or you can have an A and an O. You can have two B's, or you can have a B and an O. To get AB, you have to have an A and a B allele. And to be O, you're just OO. You can do it either way. You can use the I's, or you can use just the letters. Whatever way makes you more comfortable. So when you're looking at blood typing, you're going to be looking at each parent, and you're going to either using the I's or the A's, and the I's or the B's. You're going to put, in this case, we have two heterozygous parents. One has type A O blood, and the other has a type B O blood. So they're both, this one is A, this one is B. And so we're going to have 1/4 probability of having AB blood, 1/4 probability of having just B blood, 1/4 having just A, and 1/4 having II or O blood type. This same slide, oh, I didn't do it. Okay. I could have changed it to where it was just big A, big B, and then over here would have been BO, and then here would have been AO, and this would have been OO. We also have some genes have more, or some characteristics have more than one set of genes that interact. So instead of having, hairy knuckles is characterized by big S, little s, it might be that you have a characteristic that has multiple genes that influence it. So skin color is an example of multiple alleles that come into play, or multiple genes that come into play, not alleles, I'm sorry, genes. So, and this is known as polygenic inheritance. And so in this case, you're going to be adding up the number of dominant alleles. Each dominant allele has an additive effect on the phenotype. And so here we've simplified it by looking at just two types of alleles, or two genes, but skin color actually has like 3 or 4 genes that influence it. And so we get this bell-shaped curve where we have individuals that have very dark skin on one side, individuals with very pale skin on the other, and the majority of individuals are somewhere in the middle. If you have all dominant alleles, then you're going to have darker skin. If you have all recessive alleles, you have very light skin. Anything in between is going to be that medium colored skin. And so a medium, like brownish color skin would be the most common skin color. And then you have that lighter color, that darker color that leads into the darkest. And this is where you see bell-shaped curves. Height can have, or is associated with polygenic inheritance, but it's also associated with environmental influences. So not only do we have multiple genes that influence your height, but the environment that you're in will influence your height. So think about if you are in an environment where you get lots of nutrition, lots of exercise, then you're going to be able to grow easier than in an environment where you get very little nutrition. That doesn't mean that if you're short, you didn't have enough nutrition. But if you don't get the nutrients you need, then you can't grow properly. Whereas if you're getting all the nutrients, then you're going to grow well. Does that kind of make sense to everybody, I hope? I have 4 kids. They've all received adequate nutrients. They've gotten food. 3 of my 4 kids are tall. 1 of my 4 kids is on the shorter side. That doesn't mean that he didn't get any nutrients or anything, but his genes influence his height, but so did the environment. So if he wasn't getting the nutrients, he'd probably be smaller than he is now. And so here we see the extremes, very, very tall people, all the way down to very, very short people. And the majority of people are in this middle. So we see a similar bell-shaped curve where we have, 5'5", 5'6", 5'7", 5'8", and 5'9" become more common, even 5'10", become more common than 5 foot or 6'5". Temperature is another environmental influencer. So temperature can actually cause your phenotype to change. These are Himalayan bunnies, and Himalayan rabbits have dark extremities, and then they have a white fur coat. The dark extremities are associated with the regions of the body that are colder. So typically we get colder on our extremities. The warmer regions are where the blood courses through more often. And so the torso is going to be warmer than our arms and our fingers, which is why our fingers in the wintertime when we're outside are the first things to start getting cold. Fingers, ears, nose, toes, stuff like that. Well, with bunnies, it's their ears, their paws, and their nose as well, because those are the extremities. And in those areas, the dark fur is associated with genes that are affected by the temperature. So they have colder temperature, so they have darker fur. If you were to take, and so what they've done is they strapped an ice pack onto the bunny to cool the hair, the skin, and to activate the melanin producing proteins. And that causes more melanin production and changes the fur from white to black. So it can influence the environment can influence Our genes associated with the foods we eat as well. So I already talked about PKU, where if you eat phenylalanine and you have this disease, that's going to affect your mental aptitude. Lactose is another milk sugar that some people cannot break down very effectively. And if they don't have the proper enzymes, then the lactose sits in their gut and it causes gas and all kinds of other bloating issues. And so here's an example of where the environment that you choose will influence your health. So if you are normal, so this is normal for lactose production, it's completely dominant. So if you have big L, you make the enzyme that you're supposed to, lactase, to break down lactose. If you have big L, you again have that dominant allele so you can break down lactose. Now, there are certain types of non-dairy milks, like soy milk, silk, if you've ever heard of it, almond milk is out. Where you can have a diet where you do not have actual milk. You're using plant-based products to fill that area. So if you have two dominant L's, so you can produce the enzyme, then you're going to be happy with or without milk in your diet. You look the same. If you have one allele for the ability to produce lactose, or lactase, I'm sorry, again, you're going to be happy. But if you are recessive for this genotype or for this phenotype, then, so the genotype is that, then your phenotype is going to be different. If you have milk in your diet, you're not going to be very happy. But if you don't, if you choose to stay away from milk, drink silk instead, then you're going to feel a lot better. That is the end of this chapter. And so I'm going to stop here and we're going to discuss this tomorrow night. So you have a wonderful evening and I will too. Bye.